All right, so here we go. Today we're looking at solving linear systems of equations by elimination. The last two we've done by graphing and by substitution have worked really well for everybody so far. So elimination is just what it sounds like. We're trying to eliminate one of the variables. And like substitution, it's going to involve algebra. There's no graphing. And the first part of this is looking at how do we get rid of one of those variables, and what's the easiest one to get rid of. And in this case, you look for which x or y are similar. And by similar, I mean they have the same number in front. So that thing in front is called the coefficient. So in this case, we see that our 2x and our negative 2x are really similar to each other. They've got kind of the same coefficient with a negative and a positive. And what we're going to do is we're actually going to treat this like an addition problem. So we're going to draw a line underneath it, and we're going to decide we're going to add these together. The reason why we want to add them together is that 2 plus negative 2 is 0. So what happens is that coefficient, that number in front of the x's, goes to 0. So you've effectively eliminated the x. So we said our 2x plus negative 2x gives us 0x. So that means that this is gone. There's nothing there. But now we can still add our 2y plus y. So 2y plus y gives us 3y. Our equal side comes straight down, and we add 13 plus 5, which is 18. So we get 3y equals 18. Now to get y by itself, so we've eliminated the x, that's gone. To get y by itself, we're going to divide by 3 on both sides, so y equals 6. Just like substitution, now that we have one y, we have a y by itself, we still have to find the x. So we're going to plug this y back into one of our equations. So let's just put it in the first one. So our first one would be 2x, the color doesn't work very well, 2x plus 2 times our 6, because that's our y, equals 13. And now we're just going to solve for this by multiplying 2 times 6. So 2x plus 12 equals 13. Subtract 12 from both sides, so 2x equals 1. Divide by 2, so x equals 1 half. So that means that our coordinate that works is 1 half, comma, 6. Now think about that. With 1 half, comma 6, that 1 half x value is going to be between the 0 and the 1. So solving this one by graphing would have been really, really challenging because you're halfway between 0 and 1. So elimination works much better for this one. Substitution also might have worked by getting y by itself, but elimination works really well because of the fact that this negative 2 and the positive 2 are together. So we're kind of thinking about which one would you choose for which situation. So that's elimination. Look at another one. All right, so solving linear systems of equations by elimination again. So we've got 1.2x plus 3.7y equals 3, and 1.2x plus 0.7y equals 9. In this case, our x's again are the same with a 1.2 and a 1.2. So what we're going to do is, instead of adding this time like we did last time, we're going to subtract. So you can add or subtract. It doesn't really matter which one you choose. So now we're subtracting straight down. So 1.2x minus 1.2x gives us that 0x. So there's nothing here that's been eliminated. It's gone. 3.7y minus 0.7y gives us 3y. Bring our equal sign down. 3 minus 9 is negative 6. Again, dividing by 3, y equals negative 2. And we're going to plug that back in. So let's plug that back into our second equation, just because I like the 0.7 better rather than the 3.7. So 1.2 x plus 0.7 times negative 2 equals 9. And we can multiply our 0.7 and our negative 2. So 1.2x plus a negative 1.4 equals 9. Adding the 1.4 to both sides, you get 1.2x equals 10.4. So now we just need to divide that. So 1.2 dividing by 1.2. And as an answer there, what do we get? 8, something like that. Let's grab a calculator. So 10.4 divided by 1.2 gives us 8 and 2/3. So 8 and 2/3. thirds. So again, it gives us an exact answer rather than having to be kind of guessing between there. So we get 8 and 2 thirds, comma, negative 2. All right, I'm going to put another one up here on the board for you. So you see that right there. And we're going to try and get that one by itself. Before I let you loose on this one, I want to get this kind of in a better situation for you. So you can move the negative 3x over. So our top equation stays the same. And our bottom equation, after we moved it, so you can move the x's and y's around, negative 3x plus 5y equals 10. All right, so go ahead, pause your video, and take a second to work this one out. We'll get back together in a little bit once you finish that, and you can unpause it, and we'll go through it. All right, so in this situation, we are going to add these two together. So the 3x plus negative 3x gives you 0, so that's gone. 4y plus 5y gives you 9y, and that equals 18. So remember, I moved that negative 3x over so that I had the x's lined up, the y's lined up, and the numbers lined up. That's really key to make sure that it's like x on top, x below it, y on top, y below it, number on top, number below it. So now to get y by itself, we're just going to divide by 9, so y equals 2. Then we're going to look at how do we solve for that, how do we get that x value. So we're going to plug that 2 back in. I probably would plug it back into this first one. So we have 5 times 2 equals 10 plus 3x. We can subtract 10 because that's going to equal 10. So we'll subtract 10 from that also. So we get 0 equals 3x. Divide by 3, so x equals 0. So the coordinate we're at is 0 and 2. All right, we will see you in class tomorrow. Hopefully this has given you that third situation ready for you to work on. And we'll see you tomorrow.